Okay, in this mixed ANOVA, we're looking at a mixed ANOVA with an interaction. So here's our data set here, and hopefully in your data set, whenever you decide, if you ever do research, hopefully you've got more than 12 people here. It's just for demonstration purposes only. So the way that you would set out mixed ANOVA is you would have your ID variable there, which just tells you what the identification is of each individual. Then you've got your between subjects gender variable, and then you've got your each level of the within subjects variable. So I'll step through that in a bit more detail. So let's have a look at the variable view just to get a bit of an explanation of what each variable is. So gender, it's a between subjects variable. So 0 is female and 1 is coded as male. So there are 2 levels to gender. Then you've got pre-test self. So that's the pre-test self-report scores. So this is a confidence building program run quite intensively, and it's just a participants' scores on confidence prior to the confidence building workshops. And then post-test self, that's just post-test. They're straight after the intensive workshops. There's a post-test which they self-report on their level of confidence. Then there's follow-up self. So 1 year later, they do a self-report test or a quiz or a survey on their confidence levels. At the same time, what we get is a pre-test. A psychologist who's working with this individual, and they score this individual on their levels of confidence. Then immediately following the intensive confidence training, the psychologist scores them post-test on their confidence, and then 1 year later, the follow-up scores for the psychologist on that particular individual are measured. So what we can see here, if I went to data view, if I go straight to participant 8, ID 8, I can see this person is coded as 0 for gender, so they're a female. Their pre-test scores on confidence were 33. They scored themselves when they did the survey at 33. Post-test, so immediately after the confidence training, they scored themselves 70. And then 1 year follow-up, so 1 year later, they had a score of 25. And at the same time, the psychologist was scoring them on their confidence levels. They scored at pre-test 25. The psychologist scored them at 75 post-test, and 1 year follow-up scored them at 20. So let's before we actually move forward to a mixed ANOVA, the first thing we want to do is just evaluate some assumptions. So the first assumptions we want to evaluate are normality and outliers. So we want to split the variable or split the data on gender, so we can look at those repeated measures levels. So let's do that. So let's go data, split file, and I'll just want to split the data by gender. So what that's essentially saying is anything I do from now on, I'm going to look at just males by themselves and just females by themselves. Go OK. Let's go back to our data set. So as we've done previously, we're going to go analyze, descriptive statistics, and explore, and we're going to grab all those repeated measures levels. What we're going to ask SPSS is just to conduct a normality test on it and check out for univariate outliers. So let's look at statistics. We don't need to change anything there. Let's go to plots. Now let's just take off stem and leaf, but I would advise you to leave stem and leaf on in your own analysis of data. But just for brevity reasons, I want to just do box plots here. Give me a graphical representation of what's going on, and formally test for normality across male and females for each of those repeated measures variables or levels. Let's go continue. Options, don't need to change anything there. Don't worry about bootstrap in this case. And let's press OK.
Shapiro-Wilk test is a standard test of normality. Both it and the Kolmogorov-Smirnov test tests a null hypothesis that the data are normally distributed. Now, they very often lead to the same conclusion, but in the event there's disagreement, such as in meditating extroverts, in the previous example, then use the Shapiro-Wilk. Now, if the test is not significant, so in other words, the sig value is greater than 0.05, then the null hypothesis is retained and the normality assumption is met. So the data are assumed to have come from a normal distribution. If the test is significant, so in other words, the p or the sig value is below 0.05, then the null hypothesis is rejected in favour of the alternative hypothesis, and the assumption of normality is not met. So in other words, it's violated. Now in this case, we can see the significance for all groups of scores for the Shapiro-Wilk test is non-significant. So we can conclude that the assumption of normality is not violated. Now histograms, stem and leaf plots, box plots, they're all good to be used as a visual interpretation of the data. So here I show you a box plot as I have in previous lectures, and they can be useful just to see how normality is going, whether there's symmetry across the distributions, and also for looking for potential outliers. So here you can see that the box plot is roughly symmetrical for females in each of the conditions. Potential outliers and extreme scores are indicated in box plots by an empty or coloured circle respectively. The star represents an extreme value. If you wanted to confirm any suspected outliers, then you can obtain the z-score of the participant's score for each cell. And any participant with a z-score of more than 3.29 would be an outlier. So I'll need to check this out with the follow-up scores for the psychologist. Here you can see that the box plot is roughly symmetrical for males and confirms the results of the normality tests shown previously. Potential outliers in the follow-up scores by the psychologist also seem to be evident here. Now if you wanted to confirm, as I said before, any outliers, then you would do a z-score on that particular cell, and if it was more than 3.29 then that would be an outlier. So I'll need to check this out for the follow-up scores for the psychologists. Now in the interests of brevity, I've conducted this outlier analysis already, this univariate outlier analysis already, and found no outliers. So in other words, there were no z-scores across each of the cells that were more than 3.29. However, this has not been included here.
Okay, so we've evaluated normality and we've evaluated whether there are any outliers. Before we move forward, if you haven't taken your split file off, then please do. So go to Data, Split File, and make sure if you do have anything in there, just make sure that you've got that highlighted there. Okay, so in other words, so previously you would have had something like that. So please just make sure you tick that so we're looking at the entire data set, we're not split filing. Okay, so let's go back to the data. So what we're about to do is we're about to evaluate the homogeneity of variance with the Levene's test, the Morchley's test of sphericity, so that's on the repeated measures, and we're about to conduct a mixed ANOVA, a mixed factorial ANOVA. So let's go to Analyze, General Linear Model, Repeated Measures. Now, the first within subject factor name, well, one of the first things is we can see that there's a pre-test, a post-test, and a follow-up. So it looks like to me there's a within subject factor name of time. It seems to be a natural variable to call it. And it's got 3 levels: pre-test, post-test, and follow-up. So let's put 3 levels there and go add. Now the other within subject factor name, it looks like the people who were doing the confidence training were self-reporting for themselves, and there was also a psychologist reporting for them at the same time. So there's a within, in fact, let's call that source of the person doing the reporting. So it's 2 levels, either self-report or the psychologist was reporting. And let's go define. Now all of a sudden you've got 6 question marks there, which is every combination of time via source. So we got within subjects variables of time and source. So it's asking us here to tell SPSS what variables to put there in the question marks. Now here we need to be super careful, because if we get this wrong, then we get the whole lot wrong. So the next spot where I want to divert your attention is where it's got a question mark, open bracket, 1, 1. So what that's essentially saying, the first one is saying the first level of time, which is pretest. And that one there, that second one, is saying the first level of source, which is when the person themselves self-reports. So 1, 1 essentially means pre-test, self-report. So it's that one there. So let's look at the next question mark. That's asking me for the first level of time, which is pre-test. First level of time, which is pre-test. And the second level of source, which is when the psychologist gave the report. So this is pre-test psychologist. Now, this question mark is saying, okay, for the second level of time, which was post-test, first level of source, which was yourself, with the self-report. So it's post-test self-report. Now this is asking for post-test, second level of time, second level of source, so it's post-test psychologist. Then the third level of time, which was follow-up. The first level of source was the individual who self-reports, so follow-up self-report. That only leaves one other, follow-up psychologist, which was 3, the third level of time, second level of source. Okay, so we want to be clear that we're getting that right first. Now we've got a between subjects factor of gender. So now that we've entered all that in, we've got a bunch of options up here, and pretty much the option we're interested in are options. Let's click on options. Now we're interested in the main effects, and there'll be 3 main effects, one for gender, one for time, one for source. There'll be 3 two-way interactions, and there'll be 1 3-way interaction. Let's grab the whole lot. And we're going to park that over to display means for. When we park it over there, this box is going to become available. So let's tick compare main effects, and we've got 3 options. Let's not choose Tukey LSD. Pretty much in every instance you're not going to choose that, because we want to be able, this option does not adjust for family-wise error. So our option is Bonferroni or Shadak. We'll choose Shadak because it's slightly more powerful. And we've got, let's choose descriptive statistics, will give us the mean, measures of central tendency. Let's choose our estimates of effect size, observed power. Now because we've got a between subjects measure there of gender, let's choose homogeneity test as well, and press continue. Now whenever we're looking at any interaction or anything like this, we really want to get some plots going just so that we can see what's going on. So let's click on plots. Now we've got a few factors there and a few options. So let's choose time as our horizontal axis, and source, separate lines. So we're going to create a separate line for self-report and a separate line for the psychologist report of that individual. And let's do separate plots for gender. Separate plots for male, separate plots for females. And let's go add and continue and press OK.
You can see in the descriptive statistics that the mean and the standard deviations for each level of the independent variable for both males and for females. You can see that they're all provided. You may want to examine these means and standard deviations to see what's going on. So here I can see that post-test was rated highest by the self and the psychologist for both males and females. There also seems to be some difference in variability, with males having a higher variability in their scores than females. Now Box's test for equality of covariance matrices can be used to determine whether the data violate the assumption of homogeneity of covariance matrices. Now if Box's M is significant, the assumption has been violated. Now in this particular situation, it was not computed, so the assumption is not violated in these circumstances. If Mauchly's test of sphericity is non-significant, that is, the significance is greater than 0.05, the assumption of sphericity has been met. In this example, the statistic is 0.324, with a significance value of 0.006. Since the sig value is associated with the statistic is below 0.05, then the sphericity assumption is violated. So if the sphericity assumption is violated, a correction is applied to the degrees of freedom, and the significance of the F ratio is ascertained using the new degrees of freedom. Now the correction is obtained by multiplying them by a value known as epsilon. Now epsilons are the extent of the sphericity, with 1 equal to perfect sphericity and less than 1 being the magnitude of departure from sphericity. Now SPSS produces 3 epsilons, so you don't have to do the hard work. Epsilons are already constructed by SPSS. The 2 that we are interested in are the greenhouse geyser correction, which tends to be more conservative, and the second is a Huynh-Felt correction, which tends to be more liberal. The two often lead to the same conclusion, significant or not, in which case a greenhouse geyser is normally reported. When they don't agree, one simple recommendation is to use the Huynh-Felt correction when the epsilon values are around 0.75, and to use the greenhouse geyser correction when they're definitely below 0.75. Now in our analysis, we can see that the epsilon value is less than 0.75, so we're going to use the greenhouse geyser correction. Now you never have to do this in SPSS, as SPSS does all the hard work for you. So in practical terms, if the sphericity assumption is violated, you need to read and report the results of one of the epsilon adjusted tests on the next table, rather than sphericity assumed. Now you may also notice that there's a dot for the variable of source. You might be thinking that SPSS has failed to calculate a significance value or it's holding it back from you, but this is not the case. If you remember, sphericity is calculating the variance in the difference between two levels. Now if you only have two levels, then there's no variance in the different scores, because you only have one set of difference scores. So in other words, there's perfect sphericity and the significance test can't be computed. Now this looks like a bit of a horrible table, but we don't have to worry about all these rows. Now this shows the results of the repeated measures part of the ANOVA with the corrected F values. The output split into sections and refers to the effects and the error associated with each of the effects. Now because Mauchly's test was significant, in other words, the sphericity assumption was violated, we can't use the sphericity assumed row. As previously mentioned, the corrected degrees of freedom is the greenhouse geyser correction. So what this means is that we're only interested in these rows. Looking at the main effect of time, we can see that the F ratio is 47.721. As you can see, it's significant with a sig value of 0.000, which is definitely less than 0.05. Consequently, we can conclude that there's a main effect of time. In other words, there's a difference somewhere among the different levels of time. What we don't know is whether the difference is in the confidence is between pre-test and post-test, or is it between post-test and follow-up, or is it between pre-test and follow-up? We don't know yet. Looking at the two-way interaction between time and gender, we can see that the F ratio is 7.497. And as you can see, it is significant with a sig value of 0.015, which is less than 0.05. Consequently, we can conclude that there's a significant interaction between time and gender. Now looking at the main effect of source, we can see that the F ratio is 5.906. And as you can see, it's not significant, a sig value of 0.767, which is greater than 0.05. Now looking at the two-way interaction between source and gender, we can see that the F ratio is 0.184. As you can see, it's not significant, sig value of 0.677, which is above 0.05 alpha level. Looking at the two-way interaction between time and source, we can see that the F ratio is 0.446. Now as you can see, it's not significant. Again, the sig value is 0.629, which is more than 0.05. Looking at the three-way interaction effect between time and source and gender, we can see that the F ratio is 0.192. And as you can see, it's not significant. The sig value is 0.808, which is more than our alpha level of 0.05. So the main effect of gender is listed separately from the repeated measures effects in a table called tests of between subjects effects. Now before looking at this table, it's important to firstly check the homogeneity of variance assumption, which is done with the Levene's test. So SPSS does an homogeneity of variance test between males and females for pre-test self-report. It does another homogeneity of variance test between males and females for pre-test psychologist score. It does another homogeneity of variance test for each of the repeated measures between males and females, asking the question, is male variance different to female variance? And as you can see, they're all not significant. So luckily, the assumption of homogeneity of variance has been met for the between groups, males and females, on each possible combination of the repeated measures variables. Now, ANOVA is not particularly sensitive to violations of equal variances when the samples are relatively moderate to large and of equal numbers. So when designing your study, aim to have a relatively equal group size, moderate to large sample size as well. So here is a main effect of gender. It has a significance value of 0.435. Thus, the main effect for gender is not significant. So what do we know? If we look at the main effects, there was a significant main effect for time. There was a non-significant main effect for source, and there was a non-significant main effect for gender. What about when we look at the two-way interactions? There was a significant interaction between time and gender. There was a non-significant interaction between time and source. And there was a non-significant interaction effect for source by gender. What about when we look at the three-way interactions? There was one three-way interaction, and we see that there was not a significant effect for time by source by gender. But what we don't know is where the difference in the main effect for time is. Is it between pre-test and post-test, post-test and follow-up, or pre-test and follow-up on measures of confidence? So to do this, we need to go to the pairwise comparisons that we requested in SPSS. Similarly, we don't know where the two-way interaction between time and gender is. Now, as the main effect of time was statistically significant, it's useful to determine specifically where which confidence scores are different from which in which time periods. The Shadak post-hoc results tell me or show which times differed from which. So the mean difference column shows the value of the I column mean to the left minus the J column mean. Where there's an asterisk beside the mean difference, the two means are statistically different from each other. Now this will be supported by the sig value and the 95% confidence value. Remember too that these tables are a little confusing as they also double up. So the asterisk tells us that there are significant differences. So what we can see here are that the post-test scores on confidence were significantly higher than the pre-test scores on confidence. We can also see that the post-test scores on confidence are significantly higher than the follow-up scores on confidence. And we can also see that there's no significant difference between pre-test and follow-up scores on confidence. However, all of this is of limited interest in view of the significant two-way interaction between gender and time. Now, given the significant two-way interaction between gender and time, these are the important marginal means that represent the interaction. The remainder of this lecture is devoted to unpacking the significant interaction between gender and time. To do this, we're going to break down the significant interaction into simple effects and then do analytical comparisons with decisions made in advance about how to deal with family-wise error. In the case of repeated measures, the simple effects are one-way ANOVAs and comparisons are t-tests, which will use the Bonferroni adjusted alpha levels. There's debate in this area there's a debate in this area about the best way to go, but exploring this is beyond the scope of this lecture and indeed the course. So the research focus of the study is whether the confidence building program resulted in improved confidence, both immediately after the program and also after a 1-year follow-up. So given that there was a significant interaction between gender and time, we can use a split file to perform the repeated measures analysis, i.e., that is the simple effects, separately for males and for females. We will then rely on the compare main effects option to pinpoint the differences between the three levels of time. But this is a little wasteful given our research question. Instead, we're going to use SPSS option of simple contrast that compares every level of the repeated measures factor to a reference level, either the first or the last. with the first level, the pre-test, being the appropriate reference level in this case.
So what we've found so far is a gender by time significant interaction. So the next step is to unpack this gender by time interaction. So the first thing we want to do is split our file by gender. So let's go to Data, Split File, and you'll see that I've already done that. But if you haven't already, so let's just grab gender and park it over there and make sure that you're comparing groups and press OK. Now let's open up our data set again. And essentially, now what we want to do is conduct a one-way repeated measures ANOVA, but then do a contrast on that. And the contrast we want to do are for time. So what we're going to do is we're going to go to Analyze, General Linear Model, and Repeated Measures. And you probably already have that sitting there simply because you've already done it previously in today's lecture. So let's just go Define, and all that will be set up already for you. So again, your options are probably going to look a bit like that. Make sure you got time source, time by source in there. Compare main effects, and probably one of the differences is just have the LSD none. So because we're going to adjust this manually, so we're not going to adjust with a Bonferroni or Shadak, we're just going to divide by the number of tests that we actually do, and that'll be our new adjusted alpha level. You may have had these ticked, so let's just take those off. And all we want is just estimates of effect size. You probably don't need anything else. Well, you don't need anything else. We're just trying to reduce the amount of data coming your way, that's about to come your way. Press Continue. Now let's press Contrast. Because we want simple contrast for time, and that's really the only contrast we're interested in, let's just make sure that that is simple, and we're going to contrast it by the first reference category, so level 1, and press Change. Now press Continue.